Hi guys, welcome back to the next part. So let's see the question part 2. So in this will be, in the last part we had understood about KNN, and here we'll be seeing SVM, that support vector machines. So we'll be doing the same thing for the same data set. So let's jump into the problem statement. So again, the problem statement says the same thing. We'll be focusing on data preprocessing, feature selection and evaluation using multiple metrics to understand better SVMs. That is the classification tasks. So now the key steps that they've given are loading and inspecting the dataset, handling missing values using Canon imputer, scaling features using min-max scaler, perform optional feature selection, splitting data into training and testing dataset, training SVM classifier using linear kernel, evaluate the model using accuracy, precision, recall, and F1 score. Alright, so let's see the code. So first, we are having a function that is load iris data. So in this, we'll be loading a data frame directly, that is iris, and now we'll be assigning it to a variable df for our convenience. We'll be dropping the target columns from x, that is a target column from x, because that is a output what we need, so that would be in the y. So we'll be taking x as everything else other than target, and y is the only target. We'll be returning x and y. So this is the first part of the code. So let's see the second part of the code, that is handling missing values. We have a function and we have taken n neighbors as 3. So basically we're using Canon imputer with nearest neighbor is basically 3. We'll be trying to fit the whatever imputation we have done, that is we'll try to fit that into separate this thing called x imputed, and then we return x imputed. So this is basically after handling the missing values, we have x imputed. Now we'll see how to scale. So now we have scale features of x. So basically using min-max scaler, so it basically brings everything between 0 to 1. And for x scaled, we have a separate variable called x scaled, which will try to fit the transform, which will try to scale from x. So basically from x we have x scaled, and then we're turning x scaled. So x scaled is basically after scaling all the values from x. So then we have to select whatever feature we need. So in this, what we do is we take a function select k best, and with k values we have taken as 3. So we'll be trying to take the best k out of all the values. And now we have a separate thing called x scaled. So in this, what we'll do is basically this selector, that is after by selecting the best k, we'll try to fit that model. We'll try to train that model using the following values of x and y, and then we're returning x, y selected. So we're taking test size is 0.2, so that is 80% of the data set is used for training and 20% is used for testing with random state 42, so that the same data is used repeatedly. And yeah, that's it in this function. So basically we'll be training that. And okay, so stratify y. So what is this stratify y? This is a new thing. Okay, so basically stratify y is basically we have all the positives and negatives 50-50% in both. That is basically we have 1 or 0 in the output. So basically equal number of ones and equal number of zeros would be there for training and testing. So now we'll train the SVM model, and we'll be using the linear kernel to training. So we have 3 types of kernels, that is basically linear, RBF and poly. So linear is basically it tries to separate using straight line, and polynomial is a different polynomial, and RBF is not a straight line, non-linear line it tries to take. So this will be using linear. So the classifier is SVC and kernel is already mentioned as linear. So we'll try to fit the data. That is basically we'll try to train the model using X-train and Y-train, and then we'll returning the classifier. So to evaluate the model, we have taken certain categories, certain things. So this basically in report we have accuracy, precision, recall, F1 score. So these are the entire things which we have taken. So we'll be calculating everything for the predicted data set. So basically we're trying to get the data set Y predicted using the classifier model, giving the data as X test. So we already trained it here. So this is evaluation, and then we'll be calculating accuracy, precision, recall, and F1 score for each. So now we'll have to, so now we did for one kernel, that is linear. So basically now we have to do for all 3, that's linear, RBF and polykernel. So similarly, like last time, we'll have a dictionary called results, and then for each kernel we'll be trying to train the model using that SVM, and kernel is already mentioned as whatever is given, and then we'll be trying to extract report for each, and then we'll be printing the report. So this is the overall function. And now we have the main function. So here we'll be handling each and everything, that is from loading the data set, handling the missing values, and then we'll be having scale features, feature selection, split data, and then we'll be training the SVM model using linear kernel, and then here we'll be using all 3, that is linear, RBF and polynomial, and then we'll be trying to print the classification report for each kernel. So let me run this code. Okay. So basically dataset contains 150 rows and 4 columns because we have removed the target column now. And so this is for linear kernel, the matrix, and this is for RBF kernel, and this is for polynomial kernel. So I hope you guys understood this. Let me submit this once. So yeah, all the problem statements. So yeah, all the hidden test cases have been passed, and that's it for this video. I'll meet you in the next part.